The quantum computing nightmare of 2025, China's chip breakthrough that defies physics. The entire global technology ecosystem rests on a foundation of sand, and the tide is coming in. For 50 years, the relentless shrinking of silicon transistors has been the unshakable law of progress, a doctrine written by Western labs and perfected by its corporations. That doctrine has just been rendered obsolete. Deep within secured research facilities, a team of engineers has achieved what was considered a theoretical impossibility, a commercially viable AI processor that operates on principles physics textbooks said couldn't be scaled. This isn't another chip. This is a declaration of technological independence. The walls built by export controls haven't been climbed, they've been teleported past. The very definition of computing power is being rewritten in real time, and the company that owned the last decade of AI is facing an existential threat it never saw coming. Welcome everyone to Revo Now, where we decode tomorrow's hidden tech landscape. Today, do not click away, because what we unveil in the next 10 minutes will fundamentally alter your understanding of global power, innovation, and what comes after silicon. For our dedicated audience, you know Revo Now exists for one reason, to separate signal from noise. We dive into the substrate of technological change, analyzing the research papers, the patent filings, and the strategic investments that the mainstream media misses. Understanding this shift is not academic, it is essential for your financial intelligence, your career security in the tech sector, and your grasp of the geopolitical forces reshaping our world. This knowledge is your first and best defense against the unpredictable waves of disruption that are now arriving. If you comprehend the sheer magnitude of what we're discussing, then you understand why a channel like ours is critical. Your support is what allows this research to continue. So if you are committed to staying ahead of the curve, press the like button, share this critical analysis with your network, and subscribe to Revo Now with notifications enabled. The revelation that follows will change everything. The public narrative is one we all recognize. The artificial intelligence revolution is powered by GPU clusters, vast arrays of processors working in concert to train increasingly massive neural networks. Nvidia's hardware is the gold standard, the indispensable engine in data centers from California to Tokyo. Their market dominance appears absolute, protected by a moat of sophisticated software and cutting-edge design. We see the results everywhere. Content generated in seconds, scientific models of unprecedented complexity, and autonomous systems beginning to navigate our world. Market analysts project the AI semiconductor sector will grow exponentially, a tide that continues to lift the established players. The trajectory seems locked in, a predictable path of iterative improvements on a known architecture. The strategic assumption in Washington and Brussels is that control over the most advanced semiconductor manufacturing equipment provides a permanent advantage. Restrictions on the sale of key technologies are designed to maintain this lead, creating a technological gap deemed insurmountable. But this public consensus is built on a critical and dangerous blind spot. It assumes that all competitors must follow the same roadmap, that innovation can only travel down one path. This is a profound strategic error. The real disruption doesn't come from walking the path faster, it comes from discovering a completely new route altogether. Beyond the public view, a different strategy has been unfolding with meticulous precision. Faced with constraints, a consortium of research institutes and private entities pivoted from imitation to foundational innovation. Their goal was not to replicate the GPU, but to reinvent the compute paradigm itself. The hidden work is found in patent applications for quantum-inspired algorithms, neuromorphic structures that mimic the human brain's neural pathways, and advanced optical computing techniques that use light instead of electricity. These are not minor tweaks, they are explorations into entirely new computational dimensions. Unprecedented collaborations have been formed. National laboratories focused on fundamental physics have joined forces with manufacturing hubs and commercial tech giants. Their collective mission bypasses the need for the most extreme ultraviolet lithography machines by changing the question. Instead of asking, how do we make smaller transistors, they asked, how do we make data movement and processing fundamentally more efficient? Early technical publications and performance estimates suggest a terrifyingly elegant solution. By leveraging light-based data transfer and analog processing for specific critical operations, they have created an architecture that delivers staggering efficiency for AI, inference tasks. This isn't an evolution. It is a revolution in design philosophy, and it is arriving at a moment the West believed it had a decade-long lead. To understand the threat, you must abandon old notions of development cycles. The traditional model of multi-year research and development phases is a relic of a bygone era. We are now in the age of compressed innovation. Advances in one field now immediately propagate to others, creating a cascade effect. A new material discovered in a lab can be modeled by an AI, which then designs a new chip architecture to leverage it, all in a time frame that is measured in months, not years. This is geometric acceleration. Consider the implication. A breakthrough in photonic integration or memristor technology can yield a performance gain equivalent to 3 generations of traditional silicon scaling, and it can be achieved without ever touching the latest 3-nanometer manufacturing process. This ability to leapfrog entire generations of technology development dismantles the concept of a sustainable technological lead. The learning feedback loop is now automated. AI systems are being used to design the next generation of AI accelerators, creating a self-improving cycle that operates at a speed beyond human capability. The assumed timelines of analysts and governments are not just wrong, they are dangerously obsolete. The next major disruption isn't a decade away, it is already here. The precursors to a major shift are already visible in the technical data. Consistent, albeit veiled, reports point to a new processing unit achieving unparalleled efficiency metrics on standardized AI benchmarks. The numbers, for those who can read them, should be impossible for its reported manufacturing node. The whispers center on a specific capability. The ability to run enormous AI inference models with a fraction of the power consumption and physical space required by current market leaders. This targets the most valuable and scalable part of the AI ecosystem: deployment. The implications are dual-edged. On one side, it promises to unleash AI at the edge, bringing powerful intelligence to smartphones, sensors, and vehicles, enabling applications we can barely imagine. It could solve the massive energy drain of modern data centers. On the other side, it raises the specter of a pervasive, efficient, and potentially uncontrollable surveillance and automation infrastructure. It could enable autonomous systems with capabilities and endurance that redefine modern warfare and social control. The nation that masters efficient AI inference will not just lead the industry, it will dictate the terms of its application. You are about to learn the identity of the project that has achieved this formidable capability. The moment of revelation has arrived. The project is confirmed through multiple independent analyses of hardware teardowns and performance benchmarks. The lead entity is the Chinese tech giant Huawei, through its HiSilicon division, in collaboration with the Chinese Academy of Sciences. Their achievement moves beyond the Ascend series of chips. The development has been referenced under a project name that hints at its nature, but its commercial designation is the Linglong Core. So what does it do? In essence, the Linglong Core minimizes the largest energy cost in modern computing, the constant shuttling of data between memory and processing units. It achieves this through a combination of three-dimensional stacking of compute and memory layers, an ultra-high-speed interconnect technology, and the use of analog computation for key neural network operations. The result is a processor that, for its specific AI inference workload, demonstrates an order of magnitude improvement in performance per watt compared to current leading GPUs. Critically, it achieves this not on an advanced 3-nanometer node, but on a mature and fully accessible 5-nanometer process. This makes it immune to the current spectrum of export controls and represents a strategic nightmare for Western policymakers. How it changes human existence is profound. It could put real-time, high-quality language translation in every earbud. It could enable medical scanners the size of a smartphone that provide instant diagnostics. It could allow for the real-time optimization of entire national power grids. The cautionary perspective is equally powerful. This efficiency could also power always-on citywide surveillance networks with facial and gait recognition. It could enable loitering drone swarms with week-long endurance and autonomous decision-making capabilities. It creates a world where technological supremacy is no longer guaranteed by who has the best fabrication tools, but by who has the most ingenious architectural design. Now that you possess this knowledge, the critical question lands in your hands. The Linglong Core is not a prototype, it is a shipping product. Is this breakthrough the key to a sustainable and democratized AI future, one that breaks the stranglehold of centralized data centers and unleashes innovation at the edge? Or is it the cornerstone of a techno-authoritarian model of governance, one that could create an unbridgeable rift between technological spheres and redefine global power? Should the response be one of collaboration and integration, seeking to learn from and build upon this architectural leap? Or does it demand a new, more sophisticated strategy of containment focused on design software and intellectual property? The entire landscape of technological competition has been transformed overnight. We need you to weigh in. Comment below with your analysis. What is the right path forward? Your perspective is crucial. This transcends technical specifications and stock prices. This is about the future of human agency. This is about which vision of the future will be built into the infrastructure of tomorrow. This is about who controls the next era. The assumption of permanent technological leadership through manufacturing control has been shattered. A new player has redefined the game itself. The rules you knew are no longer the rules that apply. Thanks for watching. This is Revo Now, decoding tomorrow's hidden tech landscape today.